Technology Risk Part 4. This episode has 21 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. SDLC or secure development. What is shift-left security? Here's a strong way to approach it. Shift-left security means finding and fixing security issues earlier in the development life cycle. Examples include secure design reviews, SAST, dependency scanning, IAC scanning, secret scanning, and policy checks in CI. It reduces late-stage surprises and makes secure delivery faster. Nice. Let's continue. Question 2. SDLC or secure development. How do DevSecOps practices reduce risk? Here's a strong way to approach it. DevSecOps reduces risk by automating security checks, making controls repeatable, and giving developers fast feedback. Examples include pipeline scanning, signed images, SBOMs, policy as code, automated tests, secure templates, and continuous monitoring. It turns security from a manual gate into an integrated engineering practice. Great. Moving on. Question 3. Governance or compliance. What is ISO 27001? Here's a strong way to approach it. ISO 27001 is an international standard for establishing, implementing, maintaining, and improving an information security management system. It focuses on risk-based security governance, policies, controls, continual improvement, and evidence that information security is managed systematically. Alright, next question. Question 4. Governance or compliance. Explain the ISO 27001 Annex A controls. Here's a strong way to approach it. Annex A provides a catalog of security controls covering areas such as organizational controls, people controls, physical controls, and technology controls. Examples include access control, asset management, cryptography, logging, supplier security, incident management, secure development, and business continuity. Let's keep going. Question 5. Governance or compliance. What is NIST Cybersecurity Framework? Here's a strong way to approach it. The NIST Cybersecurity Framework is a risk-based framework used to manage cybersecurity risk. It helps organizations structure capabilities, assess maturity, and improve controls. It is practical because it maps well to cloud security, incident response, asset management, vulnerability management, and governance. On to the next one. Question 6. Governance or compliance. What are the 5 NIST functions? Here's a strong way to approach it. The 5 NIST CSF functions are identify, protect, detect, respond, and recover. Identify covers assets and risks. Protect covers safeguards. Detect covers monitoring. Respond covers incident handling. Recover covers restoration and improvement after disruption. Good. Here's another one. Question 7. Governance or compliance. What is COBIT? Here's a strong way to approach it. COBIT is a governance and management framework for enterprise IT. It helps align technology goals with business objectives, define control objectives, assign accountability, and measure performance. It is often used in IT governance, audit, risk, and compliance functions. Nice. Let's continue. Question 8. Governance or compliance. What is the difference between ISO 27001 and NIST? Here's a strong way to approach it. ISO 27001 is an international standard focused on establishing and certifying an information security management system, ISMS, a formal, auditable management process with a certification outcome. NIST, particularly the Cybersecurity Framework and 800 series publications, is a US-originated, more flexible set of guidelines and control catalogs that organizations can adopt without formal certification, often used as a practical technical reference even by organizations pursuing ISO 27001 certification for the management process itself. Great. Moving on. Question 9. Governance or compliance. What is FAIR? Here's a strong way to approach it. FAIR stands for Factor Analysis of Information Risk. It is a quantitative risk analysis model that estimates risk in financial terms by analyzing loss event frequency and loss magnitude. It is useful when leadership needs risk decisions expressed as potential business or financial exposure. Alright, next question. Question 10. Governance or compliance. What is an IT audit? Here's a strong way to approach it. An IT audit is an independent review of technology processes, systems, controls, and evidence to determine whether they meet policy, regulatory, security, and operational requirements. It may cover access management, change management, logging, backup, incident management, vendor risk, and SDLC controls. Let's keep going. Question 11. Governance or compliance. What evidence is typically collected during audits? Here's a strong way to approach it. Evidence can include access review records, approval tickets, change logs, CI or CD runs, vulnerability reports, patch records, backup restore tests, incident reports, policy documents, architecture diagrams, monitoring alerts, audit logs, risk acceptances, and screenshots or exports from control systems. On to the next one. Question 12. Governance or compliance. How do you manage audit findings? Here's a strong way to approach it. I validate the finding, understand root cause, agree severity, assign an owner, define remediation actions, set due dates, collect evidence, and track closure. If remediation is delayed, I document risk acceptance or exception approval. I also look for systemic issues beyond the individual finding. Good. Here's another one. Question 13. Cloud risk. What are cloud security risks? Here's a strong way to approach it. Cloud security risks include misconfigured storage, overprivileged IAM, exposed services, insecure networks, weak logging, leaked secrets, vulnerable images, unencrypted data, poor key management, and unclear shared responsibility. Many cloud incidents come from configuration and identity mistakes, so governance and automation are critical. Nice. Let's continue. Question 14. Cloud risk. Explain the shared responsibility model. Here's a strong way to approach it. The shared responsibility model divides security obligations between the cloud provider and the customer. The provider secures the underlying infrastructure, physical data centers, hypervisor, network fabric, and for managed services, the service itself, while the customer is responsible for securing what they configure and deploy on top of it. IAM, network configuration, data, application code, and OS-level security for unmanaged compute. The exact split shifts depending on the service model. IaaS puts more on the customer, SaaS puts more on the provider, so understanding where the line falls for each specific service you use is essential. Great. Moving on. Question 15. Cloud risk. What are the risks of public cloud? Here's a strong way to approach it. Key risks include misconfiguration, the leading cause of cloud breaches, public buckets, overly permissive IAM, exposed databases, vendor lock-in making migration difficult, shared tenancy concerns for highly regulated workloads, loss of direct physical control over infrastructure, and the expanded attack surface from the sheer number of managed services and APIs available, each with its own security model to understand and configure correctly. Alright, next question. Question 16. Cloud risk. How do you secure GCP projects? Here's a strong way to approach it. I secure GCP projects with folder or project structure, least privilege IAM, groups instead of direct user grants, org policies, restricted public IPs, VPC design, logging, security command center, cloud asset inventory, secret manager, KMS, budget alerts, labels, and CI or CD or IAC guardrails. I also enforce periodic access reviews. Let's keep going. Question 17. Cloud risk. What are IAM best practices? Here's a strong way to approach it. Grant least privilege using predefined or custom roles scoped narrowly rather than broad basic roles. Assign permissions to groups rather than individual users so access follows role changes automatically. Prefer workload identity or short-lived credentials over long-lived service account keys. Enable audit logging on all IAM changes, and review access periodically, using tools like IAM Recommender, to catch permission creep before it becomes a real exposure. On to the next one. Question 18. Cloud risk. What risks exist in Kubernetes clusters? Here's a strong way to approach it. Common risks include overly permissive RBAC bindings, privileged or root containers expanding the blast radius of a compromise, missing network policies allowing unrestricted lateral movement between pods, unpatched nodes or container images with known vulnerabilities, exposed Kubernetes API servers or dashboards without proper authentication, and secrets stored insecurely, plain Kubernetes secrets without encryption or an external secret manager. Good. Here's another one. Question 19. Cloud risk. What are the risks of Terraform automation? Here's a strong way to approach it. Risks include a compromised or overly permissioned CI or CD credential being able to apply destructive changes across the entire managed estate, state file exposure leaking secrets stored in plain text within state, drift between state and reality causing an apply to make unintended changes, and a bad module or unreviewed plan being applied to production without adequate review, since Terraform's power to change infrastructure at scale cuts both ways. Nice. Let's continue. Question 20. Cloud risk. How do you secure Terraform state files? Here's a strong way to approach it. Store state in a remote backend with encryption at rest and access restricted via IAM to only the CI or CD identities and individuals who genuinely need it. Enable state locking to prevent concurrent corruption. And mark sensitive outputs or variables so they're at least redacted from CLI display even though they still exist in the state file itself. Avoid committing local state files to version control entirely, and audit access to the state backend the same way you would any sensitive credential store. Great. Moving on. Question 21. Cloud risk. How do you approach secrets management? Here's a strong way to approach it. Use a centralized secret manager, vault, as the single source of truth rather than scattering secrets across environment variables, config files, and CI variables, and grant access via short-lived, identity-based authentication, workload identity, OIDC, rather than static keys wherever possible. Rotate secrets regularly, never commit them to version control, mask them from logs and CI output, and audit access to detect unusual retrieval patterns that might indicate compromise. Alright, next question. That wraps up this episode. Nice work practicing, and see you in the next one.